So S1 is given as sigma r equal to 1 to 10 r into r minus 1 10 CR. S2 is sigma r equal to 1 to 10 r into 10 CR. S3 is sigma r equal to 1 to 10 r square into 10 CR. Now let us do first S2. S2 is sigma r equal to 1 to 10 r into 10 CR. Now we are having a formula NCR equal to n by r, n minus 1 c, r minus 1. So apply this formula. So if you apply that formula, it is 10 by r, 10 minus 1 c, r minus 1. That is 9 c, r minus 1, r gets cancelled. 10 is outside of the sigma and expand. Then r equal to 1. So 9 c naught plus 9 c1 and so on 9 c9. This is sum of n binomial coefficient. That is 9 binomial coefficient. That is n c naught plus n c1 plus n c2 and so on n cn equal to 2 power n. This you can derive from the binomial expansion of x plus y whole power n equal to n c naught x power n c1 x power n minus 1 y power 1 and so on n c n y power n. In this, if I substitute x equal to 1, y equal to 1, then I will get n c naught plus n c1 and so on n c n equal to 2 power n. That means this will be same as 2 power 9. So S2 equal to 10 into 2 power 9. Exactly same manner we can do it for S1 also. So S1 is sigma r equal to 1 to 10 r into r minus 1 10 CR. So sigma r equal to 1 to 10 r into r minus 1. Now 10 CR I can write as 10 by r into 9c r minus 1. Again apply the same formula. 9 by r minus 1 into 8c r minus 2. Now r gets cancelled. R minus 1 also gets cancelled. So 10 into 9, 90 outside. Sigma. Now here r minus 2 onwards means it has to be defined from r equal to 1 is not defined. So you have to eliminate. Then what you have to write is r equal to 2 to 10, 8c r minus 2. That is basically you have to take that term value as 0. Now that means 90 into, when I take r equal to 2, it is 8c naught plus 8c1, 8c2 and so on 8c8. That is sum of all binomial quotient. That means it is 2 to the power of 8. That means S1 is 90 into 2 to the power of 8. S2 is 10 into 2 to the power of 9. Now S3 also can be calculated exactly in the same manner. Or else if I add these two, S1 and S2, S1 plus S2, if I calculate, that means sigma r equal to 1 to 10 r into r minus 1 plus r. That means r square minus r plus r into 10cr. R gets cancelled, which is same as what? S3. R square into 10cr. S3. Now verify the options. So sigma k equal to 1 to m k square plus 1 into k factorial. This k square plus 1 you should write as consecutive factors of after k, means in terms of k plus 1 and k plus 2. So k plus 1 into k plus 2 if I take, I should subtract minus 3k minus 1. Then again k write in terms of k plus 1. Then again add 2. Now if I multiply, this will be k plus 2 factorial, k plus 1 factorial, k factorial. Now here you combine one term and two terms here. Expand the sigma and simplify. The question. So what is the remainder when 1 factorial plus 2 factorial plus 3 factorial and so on 49 factorial when you divide with 20. Now you identify in these terms in which factorial 20 will be a factor.
5.
In which factorial 20 will
5
be a factor.
factorial.
That means 5 factorial contain 20. Once 5 factorial contain 20, is it 6 factorial also contain 20?
Yes, sir.
That means 5 factorial onwards, all are divisible by 20 only.
Yes, sir.
That means when all are divisible by 20 means I can eliminate this in this sum. Then what is the remaining now? 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial. Now you add all this. Whatever the sum you will get. Again you divide with 20 and calculate the remainder. What is the value now? 1 plus 2 plus 6 plus how much this is?
33.
Now what is the total?
33.
33. Now divide with 20 again. What is the remainder now?
13. 13.
30. That is the answer. Okay. Now, let us do in this only another problem. Add now. Find the units digit in 1 factorial plus 2 factorial plus 3 factorial and so on 2020 factorial. Third bit. Find the
Sir, 3.
Yes, sir.
last
3.
two digits. Last two digits in 1 factorial plus 2 factorial plus 3 factorial and so on 2020 factor. Now, when you want to find the units digit, now tell me how to calculate.
Sir,
Sir, 5 factorial onwards, each unit digit will be 0. And we
That
will
means
need
5
to-
factorial contain 0. That means all terms after 5 factorial onward, that is from 5 factorial onward, all are ending with 0. That means you need to calculate what only 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial value only. That already I have calculated. What the value you are getting? 33. That means what the unit digit in this? 3.
3.
So 3 is the unit digit. Why? Because all are ending with 0 only. So when you add again, so it will be same as the unit digit of this sum. But when I want to calculate last two digits, that means you have to identify in which factorial 2 zeros will be there at the end.
10 factorial.
That means 10 factorial contain 2 zeros. That means 10 factorial contain 2 zeros. That means till where I should add now? 1 factorial plus 2 factorial plus 3 factorial and so on up to which factorial? 9 factorial. In this, you calculate the last two digits. That will be the 2 digits in the entire sum.
Sir,
So go through once again. So number of 3-digit numbers x, y, z, where the condition is x greater than y greater than z. So one possible method is fixing y and then identifying the possibilities for x and z. So when I fix I equal to 4, there are 5 possibilities for x and 4 possibilities for z. And when I fix I equal to 5, there are 4 possibilities for x and 5 possibilities for z. And the minimum value of I is 1, that is y value, and maximum is for 8. That means this you can write the sum as sigma 9 minus I into I equal to 1 to 8. The value is 120. Another way is what? Because we want to have 3 digits and from 0 to 9, that means total 10 are there. In that 10, we have to choose 3, that is 10C3. And because we want only one specific order, that means whatever the 3 numbers you can choose, definitely you will have one order x, y, z, which is satisfying this condition. That way the value will be coinciding with the 10C3. So ax square plus bx plus is a quadratic expression where the coefficients are from 0, 1 to 3. Then the number of quadratic expressions are the possible values of a are only 3, 0 you cannot take, and b can be 4 possibilities, c can be 4 possible. So number of quadratic expressions are 48.
That is
So number of ways of arranging 6 gentlemen and 3 ladies in such a way that every gentleman will have a lady either side. That means we are grouping 1 lady and 2 gentlemen as one object. So 3 objects in 2 factorial ways. And the arrangement among gentlemen is 6 factorial. Or objects arrangement is 2 factorial. And 2 ladies, 2 gentlemen we have to select in one position, that is 6p2 and again 4p2 into 2p2.
so that value is 6 factorial only, na?
Correct, 6 factorial, because factorial will get simplified and it can turn out as 6 factorial again.
same step.
Go through once again. The number of combinations of 2n things taken n at a time when n of the 2n things are alike and the rest are different. So n are alike means identical objects and n are different. Total you have to select n only from 2n objects. So one possible case is n distinct you can select and 0 identical objects. That means NCN into NC0, which is 1 only. Next, n minus 1 different and 1 object. So NC n minus 1, because these are all identical, only one way. NC n minus 1 into 1. N minus 2 and 2. NC n minus 2 into 1 and so on. NC0. So sum is NC0 plus NC1 and so on NCN. So that is 2 to the power of n. So Mr. A has X children by his first wife and Miss B has X plus 1 children by her first husband. They marry and they have children of their own. The whole family has 10 children. That means let us, Mr. A has X children, Miss B has X plus 1 and A and B have Y children. Then the total family has 10 children. So X plus 1 plus Y equal to 10. That is 2X plus Y equal to 9. Assuming that the two children of the same parents do not fight, the maximum number of fights that can take place among the children. That means these X children do not fight, but these X children can fight with X plus 1 children. And X into X plus 1 plus X into Y plus X plus 1 into Y. So if you simplify and eliminate one variable, then it will be a quadratic. Then find the maximum value of number of fights, which is 33 integral value.